don't like that. That's okay. We can handle it. Yes.
Mr. Ann, can you erase the?
Nope, I'm gonna write over them. Okay, so as I mentioned, today we're doing solving exponential equations and inequalities. As before, we're pretty much just going to jump right in with an example because that's the easiest way to learn this. So the first example here is going to be to solve the equation 2 to the x equals 8 cubed. When we go to solve an exponential equation like this, or even an inequality because they work the same way, we have to have the same base on both sides. So what's my base on the left-hand side? 2. I need to see, can I turn the base that's on the right-hand side or rewrite it so it matches the base on my left-hand side? So I need to think, is there a relationship between 8 and 2? Yes or no? An exponential relationship, right? What do we notice about 8? It's 2 cubed, right? So I can rewrite or re-represent 8 as 2 cubed. And then, of course, to the third power that the 8 was being taken to. I simplify my exponents. When I multiply when I raise an exponent to an exponent, we multiply them together. So this is the same as 2x equals 2 to the 9th. The really, really cool thing that happens once I get my bases to match, the bases cancel each other out, and I'm just solving the exponential part. So then these 2's cancel, and I just get x equals 9. Luckily, I didn't have to do any manipulation there, so my answer is x equals 9.
Very handy.
Right? I really like it.
So like that, no longer
well, there are still exponents, but since the bases were the same, I only had to worry about solving the exponents so they were the same.
So if you
Yes,
took
ma'am.
2 to the 9, it's the same as
Correct. Yep. Questions, concerns, or issues so far? Do we see how that happened or how that worked? Let's do another one.
Is that a 9 or a Q?
That is a 9.
Yeah,
No. If I do a Q, I like curl it back or something. That's definitely a 9. Now I'm self-conscious about my writing.
But you're writing a 9 just like everybody does.
I know, but now I think it looks like a Q.
What other way would you write it besides
No, there's no other way to write it. I don't know.
You could
I'm really blind. Way to go, Amadive. Way to go. Okay, so here I want to do the same thing. The only difference between the way we're going to solve this and the previous problem is that I have a variable on both sides in my exponent, and this exponent isn't a singular term. It actually has 2 terms. That's okay. It's still going to work the same way. I'm only concerned to begin with making my bases match. So what's my base on the left-hand side? 9. My base on the right-hand side? Can I make 3 become a 9? In theory, but it doesn't work that way here. But I can make 9 become a 3, right? What can I rewrite 9 as so it's base 3? 3 squared. We can never make our bases bigger, but we can always make them smaller. So then this is the same as 3 squared to the 2x minus 1 power equals 3 to the 6x power. Just like before, when I raise an exponent to an exponent, that means that they multiply together. So this becomes 3 to the 4x minus 2 power equals 3 to the 6x power. I multiply the 2 into both of those pieces. What do you think it brings?
I don't know. I was just.
Okay, are you okay with this one? Okay. And now what can I do that now that my bases match? Get rid of them, and I'm only concerned with the exponents. So this becomes 4x minus 2 equals 6x, and I can solve for x. What am I going to do to solve for x?
You gotta divide by x,
Subtract
Subtract the 4x, or you could have subtracted the 6 to the left, but I tried to keep things positive. So I'm going to subtract this over here. Then I get negative 2 equals 2x. Then what am I going to do? Divide each side by 2, and I end up with x equals negative 1. Of course, I can take that negative 1, plug it back in for x, and ensure that it works. It does, so we're good to go. We really only have to check if we get more than one answer. Questions, concerns, or issues so far?
Do you need to put this in like squiggly brackets?
You absolutely can, because technically it's a set of the answers, but I'm not going to look for that here.
Whenever are you doing a simple or is you get more than one answer?
I do not believe that that's going to apply right now. Yeah.
If we do get more than one, could one not work and the other good?
Yes, just like if we try to get 2 answers, or if we have, yeah, we can get extraneous solutions, just like before. That's why if you get more than one, you should always plug it back into check. I do not believe on your homework or in this lesson that you will get more than one answer. So you shouldn't. If you do, you probably messed up. Madison. You do not have to graph any of this. Not today. Are we good for another one? Yes, awesome. There are 2 more of these, and then I'm going to show you some word problem applications.
Wait, are we see what today? I can't process words.
Wait, we have word problems?
Yeah.
It didn't function. It just didn't happen in my head a second
Can
ago.
you multiply things?
I mean, yes, you can
Wait,
do
no.
that.
I would like for you to think about this one on your own and try to solve it through on your own. Obviously, if you can't, I will go through it in a minute, but I want to give you some thinking time first.
16 times
16 times 4.
It's a really good shot.
If you don't know where to start, I always start with whatever base I'm trying to reach. So if you're not sure what multiplies together to get 64, or if I can turn it into an exponential problem, let's start multiplying 4 by itself and see if I ever reach 64. That's a wonderful place to start. Obviously, if you do that, we know that if I multiply 4 by itself 3 times, I'm going to reach 64. So this turns into 4 to the 2n minus 1 equals 4 cubed. And then I can set my exponents equal to each other and solve. So when I do, I get 2n minus 1 equals 3. I add the 1 over and divide by 2, and I get what answer? N equals 2.
I like the small one in the graphic.
Questions, concerns, or issues thus far? There are some chances, or not chances, there are some places where negative exponents will come into play on the homework. So we are going to do an example that involves those just because it is super duper helpful.
Was that not?
You just say we just do the easy one. Okay, so this is example D.
Oh, yeah.
So I'm adapting the one that you already have written in your notes.
I'll just erase that one.
Okay.
I don't like this one.
I really do like this
I don't
one.
know what's going on. You do.
Oh, wait.
I
feel like it's the negative exponent. You just flip it, right?
Hold on, hold on. The first thing I have to ask myself is there anything that I can break 5 down into so it goes to a different base? No. So that means I'm dealing with a base of 5. That is a certainty in this problem, which means my left side is going to remain untouched, and my right side is what I'm going to have to change. The only number that I can change here is 125. Is there any way to rewrite that with a base of 5 using an exponent?
Negative. Like a negative exponent.
5 times itself how many times equals 125? I heard 2 answers. 3. 5 times 5 is 25. 25 times 5 is 125. Think about quarters. 5 quarters equals $1.25. So that means that this is the same as 5 to the 5x equals 1 over 5 cubed to the negative x minus 2 power. Are we all okay with that?
I don't like it.
You don't have to like it, but are we all okay with it? I don't know about you, but I will absolutely not do anything if I have a number in my denominator. So I need to bring that up to the top. What happens to that exponent 3 when I bring it to the top? Becomes negative. So this is equivalent to 5 to the 5x equals 5 to the negative 3 to the negative x minus 2 power. Those are the exact same. This and this are equivalent to each other. And now it's going to work just like all the previous problems that we have done. When I raise an exponent to an exponent, I multiply them together. So this becomes 5 to the 5x equals 5 to the 3x plus 6. My base 5s are going to cancel, and I'm going to have 5x equals 3x plus 6, and I can solve for x that way.
You spoiled it again. Not very cool. Not very passionate in my head.
And we should get x equals 3.
I did not. I told you.
Oh, spoiled it too.
You divide by.
The homework was like that.
That is what your homework is like.
Oh.
These 4 problems are what I'm testing you on your homework.
I thought it was.
See,
And
you
they're
just-
all like that?
I think they're all very easy.
Well, that's
I think
not-
this is the other side.
Yeah, but who also went to college and stuff?
I think
Really
so.
funny. So let's not.
We won't talk about the number of math classes Mrs. Duran's taken. It's just astronomical.
I don't
Okay.
know what to-
I'm actually kind of curious.
It's more than 40,
Oh my god.
Wait, is there
just in college.
I have a question.
Yeah.
Is there something like besides pre-calc? Because I don't have.
You have to take pre-calc, but so you'll take first semester pre-calc, second semester trig. But then there's hopefully going to be an alternative next year so that if you choose to take a math class your senior year, you don't have to go into calculus. Instead, you go into statistics. And we might be able to find a way to bypass pre-calc altogether, but probably not. That's state standard. Yeah, so you pretty much have to take pre-calc, but then we're going to hopefully offer statistics as an alternative to
Wait, is that
calculus.
for an honors?
For pre-calc, yeah. Because you have to do 4 years. Or, I don't know, actually.
Because I just wanna
Is
get
it
my
6
normal
semesters
diploma.
or is it?
Why?
I think it's 6. I don't know. I'll have to look it up. I don't know off the top of my head. I thought it was 6 semesters of math for honors diploma. I thought it was 4 for regular.
So I would
But I might
would
be
only have to
wrong.
take 2 years. Right?
Yeah, I might be wrong. I have to talk to guidance because I don't know for sure. It changes all the time. Okay, I have no idea what time this class gets over. So awesome. I have 20 minutes.
No way, we won't use it. This one, because that was
Sorry, hold on. What?
No way.
So now we're going to start looking at word problem applications. These are things you will actually have to consider in your adult life when you're investing money or putting money away into a certain type of bank account or savings account. These are real things.
Word stuff. That's what I'm labeling as word stuff.
Words. Oh my god.
Real
Goodness.
lessons.
There are 2 types of interest. There is compound interest and there is continuously compounded interest. Today, I believe we are just looking at normal compound interest, which means all of these are going to follow this equation.
Those are just a bunch of
Okay,
letters.
that's the one.
Great. Those are literally
So then list the alphabet in front of you.
That makes it so much easier.
So A, B, C, D, E, F, G.
Is that an I or an L?
That is a 1.
Oh.
This is A equals P times the quantity 1 plus R over N to the NT power. Each of these variables stands for something very important. So A is clearly going to be the amount of money you have after T years.
So whenever we have a quiz, is this going to be
This should definitely, yeah, I'll definitely give you some.
So this is an extra credit.
Oh, that's one of my favorite word problems. Like Mrs. Duran had a daughter. She has to invest $1,000 in her daughter's future. Which account is better? Best problem ever.
So
Yes.
Yeah, money
No,
after.
you actually.
You have a double
Oh my god.
We all know that double after.
Second.
Oh my gosh, I read it like I didn't even notice.
Thank you. I do that sometimes. My brain works faster than my hand does.
I thought you said.
No, that is T years. Okay, P is the amount of money you start with or your principal amount.
So,
Okay.
Amount you started with?
Yes, amount of money you started with. I'm gonna say starting out. R is the interest rate at which interest is being accrued. We put this as a decimal, not as a percentage. N is the number of times per year your compound is being accrued, or your interest is being compounded. There we go. Times per year. Interest is compounded.
Doesn't interest like in a savings account, you get it like every
Yeah,
4
me too.
like you get it
Different
4
accounts are different. So a lot of them do quarterly, some do monthly, some do yearly, some do bi-yearly, some do every other week. It just depends.
I know I have a savings account. I got like 13 cents.
Yeah.
I had like $800.
And T is the number of years at which we will be letting the money sit in the account.
Oh my god, I want to spell it actually.
Yes, that is a very common application of this as well. So on our paper, there are 3 examples listed. We're probably not going to get to all 3, but they all work the exact same way. Okay? So if we get through one, that's obviously enough for you to do some problems if I assign them.
Should have put A after.
I should have done that. Do we all have these written? Okay, I'll give you a second.
It looks like you tried to write. I tried to say
Oh.
Duran. Looks like you tried to write apartment and just failed really bad.
It would look like this. Oh my goodness, I love it.
The
fact that we both came up with that, like, no offense, but
Okay, I'm going to assume we are all done writing, which means that we can go ahead and start an example problem. Is that true? Okay.
For the goes
Trying to spell.
Yeah, they're all kind of long.
Just ran
Yes.
$20.
People make so much money off of hanging out. It's not even Didn't someone make like 15,000 off of it?
So is everybody right gonna be like written in the story problem?
Was it 50K? I know.
Yes.
Can I come to you during college for you to do this for me?
No, but you can ask me for help and I will help you.
Sweet, so.
Yeah, I'm not
I was
right.
gonna say, I could work on my
You'd be surprised how many people contact me and they're like, Mrs. Duran, I know either you never had me or I had you 2 years ago, but can you help me? And of course I'll help all the time.
How do you pay taxes?
I don't know if I could go to a teacher if I'd never even had them.
It's actually kind of funny because like I got an email from this person and I'm like, I have no idea who you are. And they're like, yeah, one of your students gave me your name. Can you help me with this? I'm like, yes, of course.
I just wrote in.
I have some teachers I don't have more than I have teachers I have.
It is, but it's work. We don't have to.
I know, and I visit him every day because I miss his class. Yes, I do. This morning, he was my therapist, so.
You always need a therapist.
Oh, yeah.
He seems like the person to just say stuff and then vice versa.
Probably.
That's what I do to my.
So we're probably just going to do this one example and then I will try and give you some homework time.
I don't even have a subject.
I'll give you a minute to write it. So this says an investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in this account, what will the balance be after 15 years? Yes, we will use that formula and we'll fill in the important information. I always like to write the information out next to its corresponding variable. That way it makes it really easy if there are several parts to a question, because these usually have several parts to them.
Isn't this a bank's job?
No, this is your job to determine which bank or bank account to put your money in.
Darn.
I mean, I just put the one that was there.
Well, yeah, I mean, but when you're older and you're investing in things or putting money away for a rainy day in the future, these are things you need to consider.
Wait, your mom? What you started with. So would that be
Okay, it sounds like most of you have this written, so let's go ahead and pull out the important information. This is all the variables that we're going to plug into our formula. So the first one is my principal or starting amount. How much money am I investing in this account initially? $2,500. Next one I want to look at is my R, or my interest rate. What is my interest rate for this account? Okay, it is given to me as 4.2%, but we cannot plug that into our equation as 4.2. I need to change it into a decimal, which means my decimal moves how many places to the left? 2, because we divide by 100. So this is 0.042 as an interest rate.
That's a lot.
Is that a good?
That's a fairly decent interest rate, yeah. N is the number of times per year that my interest is being compounded. Anybody have an idea of how many times per year this is happening for this account?
Once annually.
Ooh.
Once annually.
15 years. Interest compounded monthly.
Oh, never mind.
What word gives it away, Jalen?
So 12 would be right.
Dang.
Monthly tells me how many times per year it's happening. If it said quarterly, that would be 4. If it said semi-annually, that would be 2. Annually would be 1. Bi-weekly would be 26 because there's 52 weeks in a year. Weekly would be 52. You just have to think about it in terms of 365 days.
Can we write that down?
Yeah.
Sometimes.
Yeah, that's fine. We'll do it. We'll try and fit it here. So N here is 12 because it did say I'm taking interest monthly. What is the last piece that I'm missing? T. And that is what? 15. It asks, after 15 years, what is my balance? Now I'm going to go ahead and write out my equation with this information, and then we are going to practice plugging it into the calculator because a lot of kids mess up here. So plugging it in, I get A equals 2,500 times 1 plus 0.042 over 12 times, or to the 12 times 15 power. Okay, so that's it written out with all the information. That's a plus. My T's have a curve on the bottom. Huh? Sure. So that is the equation. You definitely need a calculator for this. We are going to do this in batches because I don't want you to mess it up the first time you plug it in. So I am going to show you how I would plug it in, and then you can decide if that's the way you like to do it or if you want to explore on your own. But you need to be very careful with parentheses in this. Very, very careful. I would not do all at once. I would split it in half, but to each their own. Okay.
Wait, can you put that out?
You can. If I were doing this, which I highly recommend, this is at least how you start, I will always do this part first because this is where the mistake normally happens. So if I'm plugging that into my calculator, I'm going to do parentheses, 1 plus, parentheses again, 0.042, and then divided by 12, close, close. And then we're going to take that to the 12 times 15. Oh, gosh. Is that 600? No, it's not. That's 180. That makes so much more sense. So to the 180 power. If you wanted to do all of this at one time, again, I do not recommend this, but you guys are a little reckless sometimes with your math and calculators. You would put another set around this whole thing, and then you have the 2,500 in front of that. If you wanted to put it all in your calculator at once, this is how you would do it.
Why not?
I don't recommend it. I definitely recommend you break it up. Calculators have a really good memory. So you could do all of this and then just multiply your answer by that. That's how I would recommend doing it. When you have an answer, I want you to check with the person sitting next to you and see if they got the same answer. And we always round to 2 decimal places because that's how they round money.
So we would round before we multiply by 2,500?
No, I would round at the very end.
Okay, so we just push times.
Yes, now just times 2,500.
Let me do this one more time.
Is that a math yet? Yeah.
Oh, I did divide it by not
Like 8 cents.
4.
Nah, I'm smart.
It's not about.
No, being taller.
You should have gotten $4,688.87. That should be what you got.
Hooray, we can get.
Show of hands who all got that, just out of curiosity. Those who didn't, do we know where we messed up? Okay, we'll look
I
at it.
didn't know where I messed up.
Are there any major questions, concerns, or issues with everything we've done so far today? It has been requested that we go ahead and write down the N types of things that you're going to get. So just common terms that they would use for compounding interest so many times per year, and then how many times that occurs in a year. So let's go ahead and write those because it's a really good thing to think about and want to have around. So starting monthly would be 12 because there are 12 months in a year. Annually would be 1 because that's 1 time per year. Biannually would be 2 times per year. Oh. Weekly would be 52 times per year. Bi-weekly means every other week, so that would be 26 times per year. Quarterly would be 4. I'm trying to think of some other ones. They might say like bi-monthly. That means 2 times per month. And that would be 24. I can't honestly think of any others that they would throw out there except for continuously, but that's an entirely different lesson. So these are the common ones that you're going to see, and these are any that I could give you on any assessment. Okay, so make sure they are written somewhere. It's a really good reference to have. That was a good idea, Sam. Anybody have any questions, concerns, or issues for me? Okay, so whatever time is left, which is almost, 4 minutes. That's not that long. You can look at the homework. If you have questions, obviously let me know. It is due tomorrow.
I got it. Don't worry.
And if you want more examples of story problems, there are 2 more in the notes.
Not put it away.
Yes. Oh.